All right, so let's take a look at 5.4. We're doing 13 through 20 all, and number 53. So,
How do I get myself out of this?
you turn off your video. Okay, so taking a look at number 13. It says graph the data and oh, you better not have a daughter. All right.
The dude we played did have.
Graph the data and draw a smooth curve that models the relationship between Grant's income and his offering.
Hi,
Okay.
Ann.
It's little span.
Little span is here. All right, so we have a table that shows us Grant's income, which is how much money he makes, and then how much of it he gives, like to church. So what we need to do is to make a graph. So I'm just going to kind of start here. This will be number 13. I'm just going to kind of draw one. And actually, I'm going to take that back and I'm going to make it like an L shape because I shouldn't need any quadrants. Okay. So what we have are two different items, right? We'll have like income and we'll have giving. So let's put the giving down here. And so we'll do offering here. And this will be income. Okay. So your next choice then is to decide how you want to put it together. So you're going from 50 to 1,000. I'm thinking I'll make this a little bit longer. I'm gonna have 1,000 here, and maybe do it by hundreds. Okay. Or I could do it 2, 4, 6, 8, 10. Let's do like 200, 400, 600, 800, and then 1,000. Okay. So here on the offering, we're going from 5 to 100. So I'm going to top out here at $100 that he gives. And so 5, 10, 25, 50, 75. We can kind of estimate, maybe go by 20s also. So this can be like $20, $40. Get rid of that. 60, 80. Okay, so you'll need to be able to set up a chart to explain the information that you're given. Just make your best guesses here. You know, once you get in, you may say, I wish I'd done that differently, but it's okay. That's what pencils are for. All right, so income, and we'll say offering here. And if you guys will do me a favor and let me know if I'm not on the screen, that would be great because I'm just looking at the book. Yes, sir. Because I know in like one video I did that. It was like I worked the whole problem.
That was 5.3.
5.3. Yeah, it's like I had worked the whole problem and then I was like, oh wait, hit pause. Yeah. All right. So now what we're gonna do is we're just gonna graph it. First, we know that he made $50 and then he gave 5. So I'm gonna estimate 100 about right here. So I'm gonna put 50 in the middle. This would be about 10, right? So I'm going to put it about right here, just kind of in the middle. This will be like $50 and $5 offering. Next, he made $100, which would be right in the middle here before the 200, and he gave 10. So I'm going to move that up here. So already you're noticing that as he makes more, he gives more, right? 25 would fall. So he made less money this time. So we're going to go back kind of down here to the middle. No, sorry, he made 250. So if I say this is about 300, right? This is probably about 250. So I'm going to say right here. And he gave $25. So I'm going to come just above the 20. Just try to estimate it. Okay. Yeah, I'm already wishing I had done the money differently. And 500, I'll put it right here between the 4 and the 6. When he made $500, he gave 50. I'm going to try to put that between the 40 and the 60. Then he made 750. So here's 700. This will be about 750 between that and the 800. And when he made that much, he gave about 75. And when he made $1,000, he gave $100. Okay, so again, we're going to connect. And what do we notice? Again, as his income gets larger, so does his giving, right? His offering. Is there anything else you notice about the numbers? It did increase. Yeah, so he definitely made more as he went. So $50 income, $5 offering. $100 income, $10 offering. Like, does anybody see a connection between those numbers?
Yeah.
What is it?
It keeps on like going up. Like this
Mhm.
had 10. This one had 20.
250 and then 25.
Mm-hmm. And then right here, that's 225. And that was like 25, right?
Yeah.
And then we had 500.
Mm-hmm. Yep.
Respect your parents.
500 and then 50. So what you might notice is that the first number matches in both, right? So it's 50 and then 5, 101, right? And so what you're seeing here is 10%. Okay. Just pointing that out. Okay. It's like a 10% of whatever he makes, he's giving. So you can kind of see that in the pattern as well. Which takes us to 14.
Wait, so
No, what's your question?
so she says put the answers like on this side. Can I just put like 13?
Yep. Yeah, I already told you you're exempt from that. You're good. All right. So the general trend of the data, what were we just talking about? Like, what do we notice overall?
So this is the answer?
This is the graph for number 13. Yeah, all it says is graph it. Okay. So in number 14, they want to know what's the trend? What are you noticing here as you look at the graph and not your phone?
The income.
There's the income and then it's connected to the offering. What is the connection? When the income goes up,
It goes by
the
5,
offering goes up,
5,
right?
10, like it times itself by 12. By 2? No.
But a general trend, you're being very specific there, okay? But what your answer needs to be for number 14 is that when there's more income, there's more offering.
I just put when it increases.
When what increases?
I didn't write that. Should I?
You already turned it in, or?
I can unsubmit it.
Yeah. See, that's the point of that's why I sent you guys the 5.2 also, just in case you needed to look at it and
Jace,
figure out what you did
you know
wrong.
who you look like? Me? Yes, you. Me? You look like me. The red angry bird. Because you get the big eye.
All right. Everybody good on 14?
Am I wrong?
Now I've said it twice, Charlton, so if you don't have 14, it's going to kind of be on you, bud. All right. So yeah, definitely as the income goes up, then the offering goes up. On number 15, they want you to use the graph to figure out if he makes $300, how much of it will he give? And so that's one of the things we were talking about on number 15.
Yeah, like you.
Mhm. So if he makes $300, how much will he give in offerings? And we talked
like tithing wise.
yeah, like that. When they say offering, they
You
mean
just
tithing.
give like half of it or something.
Yeah, it will actually be $30 because that's one thing we talked about. And I'm just going to draw this over here, but it was like 50 and then he gave 5. If it was 100, he gave 10.
So
If it was 200, he gave 20. Yeah, so the answer will be 30 because he's giving 10% of it. Okay. That is definitely the connection. Just maybe write 10%. Okay. Number 16 says, use your graph.
30, 10%. Like.
Yeah, I'm just adding that he would give $30, which is 10%. Okay. Everybody good? Yeah, don't let me go on without you. Number 16, use your graph to determine his income if he gave $60. So if he gives 60, he made what? Well, here's the question. 60 is 10% of what?
30. Or
So don't make it complicated. It's 10%, right? Which means there's what, another 90%? So if I break this into 10 pieces, let's say 60, 2, 3, 4, 5, 6, 7, 8, 9, right? So if 60 is 10%, it would be 600, right? Because it would be another 60, another 60. That's like, think of it as a fraction. It would be like 1 out of 10, right? 60 out of what? So eventually you would get to 600 because 60 times 10 is 600. Does that make sense?
So do we put that example right there?
No, you don't have to. Then
Because it says use your graph. Oh, this.
yeah. So
we
again,
just- so for the answer, we put like 60.
yeah, this is your ultimate answer. Yep. And this we just use this to answer. Okay. All right. 13 to 20 all. Let's jump over to 17. It says
So we had 16 to 17.
we just answered number 16.
Oh yeah.
We're not doing multiples of 3. It's all.
Oh yes, yeah. It's 13 through 20 all. I see what you're saying. Okay. We've got another section, next page. And number 17 also wants us to make a graph and draw a smooth curve that models the relationship between the numbers of calories Jonathan burned and the time he spent, playing basketball. So I'm just going to make sure I'm making a regular, yeah. Okay. So looking at this, let's see,
Can you move it down?
all right. So let's go ahead and make another graph. And we have minutes playing basketball and then how many calories he burned. So we can make the bottom part like the basketball. Or you could say BB minutes, right? We can shorten that. So let's see, these are basketball minutes. And then these are going to be like the calories. All right. So he 10, 20, 30, 40, 50, 60. Okay, so this is pretty straightforward. So I'm going to go 10, 20, 30, 40, 50, 60 on my minutes. Okay, so calories are a little different. They go from 94 to 565. I think I'm just going to do hundreds up to about 600. Yeah, and so I'm going to go 100, 200, 300, 400, 500, and 600. And then we'll just put them about where they go. Okay.
Got 600 on the top.
Yes, sir. All right. So then we'll just put in some dots. Let's see. Okay, so we've got 10 minutes and he burned 94 calories. So I'm just going to put it kind of right here, almost at the 100. In 20 minutes, he burned 187 calories. So I'm going to come up from 20, just under 200. In 30 minutes, he burned 280. So up from 30, so just under 300. But we see a trend already, right? Going up. 40 minutes, 375. Okay. In 50 minutes, 470. And in 60 minutes, 565. Let's keep it right there. And we'll draw. Okay, so number 18 says describe the general trend of the data. So what do we notice? What's going up?
It's increasing
What is increasing?
calories
Mm-hmm.
burned
Because of what?
of time. played.
Yeah, the more you exercise, the longer he played, the more calories he burned, right? So the more basketball, more calories burned. Okay. I can't find mine either. Yeah, I was looking for those the other day. Couldn't find that in. Yeah, I can't even think of where we would have put them. All right, number 19 says, how many minutes does he need to play to burn 150 calories? So for 150 calories, what does he need to do?
Play 15 I put 16.
Okay, so I'm wondering, okay, so for in 10 minutes, he burned 94 calories, right? I just want to look at something real quick. And then in 20 minutes, it's 187. So I just want to take 94 and multiply it by 2 real quick and just see. So it's pretty close, right? So if we take, so you said 15 minutes. So 10 minutes would be 94. So how many would 5 minutes be? Could be half of 94, right? So half of 90 would be 45, 47, right? Am I thinking that
I
correctly?
think so, yeah.
Okay, so let's add those together. 7, 8, 9, 10, 11. That'd be 10. Be 141, so it's pretty close.
I put 16.
Okay, so 16. Yeah, so you could even say 15 to 16 minutes, right? Just kind of estimate. Yeah, because that would put 1 minute at about 10, almost, estimating. So, yeah, it'd be about right. Okay, number 20 says, how many calories does he burn if he plays basketball for 45 minutes? So if he plays 45 minutes, how many calories? Okay, so at 40 calories, he burned 375, right? Now, if we wanted to add another 5 minutes, we said that's about 47, right? So let's add those two. So this is 40, and this one's 5 minutes. 7 and 5 is 12. 8 and 4 is 12, and so we would say about 422 calories. Okay. The book actually says 425, but I think that's pretty close.
Yeah.
Okay. All right, that's 9 through
59.
that's 13 through 20.
53.
Turn this page and we'll do number 53. All right, so let's take a look at that and see what we got ourselves into.
Isn't that the only one?
I think so. Okay. All right, so 53 says x minus 4, absolute value of x minus 4 is less than 6, and they want you to solve and graph the solution on the number line. Okay, so what we will do is,
Add 4.
what happens when
You just take those out.
our variable is inside
When is your divide?
the absolute value? Not yet,
We take them out of them and just have them.
but it's
X minus
inside, so
4.
what happens?
X minus 4.
No, but listen.
It's not negative.
Okay. If you have your variable, your letter inside an absolute value, and you're using inequalities with a less than, is it just 6 or do we change anything?
She just told us just to take it out. What's the absolute value for 4?
Okay. And then what?
But the 6 isn't in the lines.
Right. So what we'll have to do is take x minus 4 less than 6, and we also will have x
Oh, we have to make it negative.
minus 4 greater than negative 6. So remember, when we take that out, then we change the outcome. Okay, it could be negative, could be positive. So we'll add here. X is less than 10. We'll add here. X is greater than negative 2. Okay, yeah, so far I'm good.
No, graph it.
Okay.
What did the total amount cost for all of the papers? How much was she going to spend?
X is less than 10, X is greater than negative 2. Okay, so looking at the graph, we have a 10, we have a negative 2, and like we'll just put 0 in the middle, right? Okay, so we have X is less than 10. Okay, so am I open circle or closed? It'll be opened. Yeah, because it doesn't include the 10. And it says X is less than 10. So I'm going to follow that arrow and it'll go to the left. Now, it also says X is greater than negative 2. So negative 2 also open, right? And it's greater than, so it's going to go in this direction. So your graph will look something like this, right? And you should have these two. Now they're connected, which tells me that these are connected. So what we want to do is rewrite our answer. With small, we're going to put the X in the middle. We'll put the smaller number here and the larger number here. Okay? And be really careful. So I've got X is less than 10, right? But be careful with the negative 2. X is greater than negative 2. So make sure that the greater than part is facing the X. You're not flip-flopping it, right? You're just writing it in a different order. So X is greater than negative 2. So this will be an answer. And so will your graph for number 53. All right. So it was 5.4. Let's take a look at 5.5, 2 through 10 odd, 12 through 33, multiples of 3, 49, and 50. Okay, so let's start a new one. All right. 5.5, 2 through 10. And all right. Remove. Let's see what we got here. So functions, domains. Let me just look it over super fast. And graph the function. Ratios. Come on. Okay. Okay, so
So what'd you get on your test? The Bible? 98.
I got a 97.
All right,
No,
so
I got 90.
all right, so number 2 says g of x is equal to negative 2x minus 3. Okay. So they want the function, rule, and domain. They want you to make a table and write a set of ordered pairs. No problem. Okay. All right, so is there a faster way to do this than
This is how I did it.
you just change the numbers out in it? Yeah, okay. Yeah, that's what I was thinking. Well, we could graph it real quick, but either way. Okay, so make a table and write a set of ordered pairs. Okay, so we don't have to graph it. Perfect. Okay, so the first thing that we know when we're given an equation like this is number 1, that -3 is your y-intercept if you're graphing it. Okay, so I know for sure there's going to be like a 0. Oh, wait, that's the x. It'll be -3, 0 in there somewhere. Okay, but what we're going to do is here's x. We're going to write the function that we've been given, and then we will solve it for y. Okay. All right, so so at this point, you really just can kind of throw in anything that you want, but you want to kind of keep it simple. So you might just start like 1, 2, 3, right? So we'll say -2 and then substitute 1 minus 3. So when we solve this, we'll have -2 minus 3. So that will actually give us a -5. Okay. So -2, we'll substitute a 2 in for the next one, minus 3. That will give us -4 minus 3, which will give us a -7. So I think I'm going to put in a 0, start going in the opposite direction, see if I can get these numbers smaller.
I thought it was 1, 2, 3.
Oh, yeah, it doesn't matter. You're just placing numbers in. So I'll have a -2 times 0 for x minus 3, which will leave us with a -3. And then let's just do like, how many do you need? Like maybe one more. Okay. Wait, how many are they doing? 1, 2, 3, 4, 5. Okay. So -1, -2. All right. So let's go -2 times -1 minus 3. -2 times -1 will be a +2. 2 minus 3 will be a -1. So does everybody kind of understand what we're doing here?
Yes.
All right. We're just substituting x and solving for y. So I'll have -2 in for x. A -2 times a -2 gives me +4. Better. Which will give me, so that'd be 4 minus 3, that will give me a +1. Okay. So if you need to, if like you can't do this and like you need to write +4 minus 3, right? Do what you have to be able to see it. Okay, so at this point, let's get some ordered pairs. And
1, -5, 2, -7, 3,
so here's my ordered pairs. Okay. And -2 and 1. Okay, so there's your table. They asked for a table, write a set of ordered pairs, and then they want you to give the function, rule, and the domain. Okay, so the function rule should be this. I don't think that it would be anything else. And then the domain is what?
Would that be like the 1 side or the 5 side?
It would be the 1 side. It'll be the x.
1, 2, 0, either 1 and
Now, remember also that you want them smallest to largest, okay? So let's start with -2, -1, and 0. So we're going to go from the back forward. And we're only writing down the value of, oh, wait, 1 and then 2. Okay. I'm going to switch these real quick. So just make sure they're in order. There's your domain. Okay, and I don't think there's any other functional. Let me
F.
What
the
is it?
F, this is what I got.
Mhm.
Bottom. The FX one.
Oh, that it equals those? Okay.
But they equal each
Oh,
other,
yeah,
so
sorry.
make it-
So they called this g of x. Let's get it. Let's be proper. Yeah. And then, yeah, I don't see anything else on here.
and that's all I did.
Yeah, so that should be.
And then 4, you're just gonna have to graph it. The FX. So these together.
On number 4?
Yes.
Number 4 has its own thing though, right?
Let me check.
Okay. So the only other thing I
Yes.
would add here is because this is the function g of, we're going to call this g equals that, okay? And that is your set of rules. All right, any questions about that one? Okay, so it's pretty straightforward for the most part. You're just plugging in. It's just when this gets a little more complicated. All right, so let's jump over to 4. All right. So number 4 says y is equal to 1/2 x plus 1. And then they give you your domain. And they have, say -4, 0, 3, and 6. Okay. So we have some information. They want us to graph each function. So let's make another table. So if this is our domain, that means these are all our x values. They've been given to us. And we're going to plug them into 1/2 x plus 1. And that should give us our y value. Okay, so let me go ahead and put in -4, 0, 3, and 6.
Mine gives us a fraction.
Yeah, but they've given you your domain, so you shouldn't use anything probably except that what's in here. Or do you? Are you talking about the +1?
Like, I put 3 in it and it gave me a fraction.
Oh, you mean one of the numbers?
Yeah.
Okay, gotcha.
Can I go to my mom to see if I can get my ankle wrapped?
Sure. All right, so let's go ahead and plug it in. So I've got 1/2 times -4
Alright, my mom.
plus 1.
To get permission.
Okay, so that is going to give me 1 and 2. It should be -2 plus 1 would be -1. Okay. And I'm just going to make sure I'm correct there, but I think I am. Is that what you got, Lucy?
Yes.
What are
Perfect.
we going to again?
Sorry,
What are we going to?
what are we going to?
Mhm.
It was 2 through 10 odd, 12 through 33 multiples of 3.
2 through 10 odd.
That's what I have written down.
And then what is
12 through 33 multiples of 3,
and
49 and 50. All right, so when I put 1/2 times 0 for x plus 1, I'm only going to have a 1 left over. 1/2 times 3 over 1, right? Plus 1.
I just put 3.
I'm going to multiply across. I got 3/2.
Why'd you put it over 1?
I just like to see it.
I got 5 over 2.
From what? 5 over 2?
Yeah.
So I had 3/2 plus 1. So I'm going to make 3/2. 2 goes into 3 1.5 times. So my answer is going to be 2.5 or 2.5. Okay. Is that what you ended up with?
No. I got
So over here, I'm taking 1/2 x, right? And I'm multiplying it by 3. I just like to put the under 1 to see it.
But X doesn't have like a 1.
No, but the x is a 3, and I'm multiplying by a fraction. So if I'm multiplying 1/2 times 3, I just change it to put the 1 under it because it's just easier for me to see. It doesn't really matter if you do or not. But this way, I can just look at it and multiply across. So I've got 3 halves. I'm going to make that a mixed number, right? And then add it to the 1. So I'll have 2.5. You don't have to write all this down. I'm just showing you.
What do I put?
2.5, 2.5. If you want to write it as 2.5, you can. And then 6, I'll have 1/2 times 6. I'm just going to put it over 1, right? Plus 1. So I'm going to do a quick inside here. I'm going to cancel 2 into itself once and into 6 3 times. So I will have 3 over 1, which is 3 plus 1, which will give me 4. Okay. Any questions about that one? Okay. Please speak up if you want to. Okay, so there is, and I think they just want you to graph it, right?
Yes, I got mine.
Okay, so here are my coordinates. I've got -4, -1. I'm going to go ahead and just write, y is equal to this set. 0, 1, 3, and 2.5, and then 6 and 4. All right, let's graph it. If you have graphing paper, even better. Yeah. All right, so here we are. Okay, so I've gotten 1, 2, 3, 4, -4, and -1. I have 0 and then 1. I have 1, 2, 3, and up 2.5. So I'm going to just put it about right there. Then I'm going to go 3, 4, 5, 6, and up 4. Okay, so I just counted over 6 and went up 4. And so I should have something that looks like this. Okay. I didn't even run it through, so I don't know. Weird. Okay, so that's number 4. Graph each function. Number 6 should be next. I'm going to go ahead and make a new page. This is a paper killer. All right, make sure where am I at? Here's number 6. It says f of x is equal to 1/3 x. Yeah, of course. All right, so let's keep going. So I'm going to have x. I'm going to have my f of x, blah, blah, blah. All right, so I'll have 1/3 x. And then I should have my f of x or y, okay, function of x. So let's make up some numbers, shall we? Let's go with, I want to do bigger numbers because
Can y'all do the ones that I did?
well, actually, I'm trying to think like what would get rid of fractions. So I'm going to go with 3.
Because I
And
don't know if I
6.
did all mine right.
Okay, we can try some of yours too. I know I'm pretty sure 3 and 6 are going to work out.
Yeah, I got 1.
Okay, yeah, you should. And I'm going to go ahead and just do 9, and I'm going to stop there because I don't want my graph to be too big. Okay.
So you're only doing 3? I did 5. She said that she wanted like 4.
Okay, let's do 1 and 2 also. Okay, so if I do 3 times 1/3, these will cancel each other, right? And I'll have 1. What's wrong, Lucy?
I'm erasing and doing what you did because I got a bunch of weird fractions.
Doesn't mean they're wrong though. When you're ready.
I'm ready.
Okay, so looking at 6, I'll have 1/3 times 6, which will give me 1/3 times 6. And I'll just put it over 1 because I'm weird. And then when I'm just looking across, 3 goes into itself once and into 6 twice, which will give me 2/1, which equals 2. Everybody good there? Okay. Same thing with 1/3, and then we'll make 9 the x. And I'll have 1/3 times 9/1. 3 into itself once, into 9 3 times. That will give me 3/1, which equals 3. And then just putting in some smaller numbers, I'll have 1/3 times 1. Charlton, you with us?
Yeah.
Okay. So I have 1/3 times 1/1, and that will just give me 1/3. And 2 will give me 1/3 times 2, which will be 1/3 times 2/1. Just cross multiply, and you'll have 2/3. Okay, well, we'll just stick with that. So this would be like 0.33 if you want to do decimals. And 2/3 would end up being like 0.66. You would just divide 2 by 3. Okay. And they want you to graph. So you can just estimate these.
Give me the put it down.
All right, so I've got 1, 2, 3, and 1. 1, 2, 3, 4, 5, 6, and 2. I've got 6, 7, 8, 9, and 3. And then I'll end up with like 1 and 1/3. So I'm just going to kind of keep it down here. And then I have 2 and 2/3. So it'll just be kind of like right here. So this is pretty approximate, right? But just try to keep yours as tidy as possible and draw your line. And that should be correct. That was number 6.
Do we list them together or no?
Yeah, that looks right. Okay, so it does not ask you to list them, but I would. So I would just say anywhere. You could even put it over here, like, so f of x is equal to the set of 3, 1.
What was that saying?
F of x. Oh, can you see it? Thank you. Okay. So I'm just going to write those coordinates in. I've got f of x is equal to the set of, and then you'll just give all the coordinates. So 3, 1, 6, 2, 9, 3, and then we had 1 and 1/3, and 2 and 2/3. Okay. Again, when you're looking at something like on this function, like a 1/3, that's why I started going with like multiples of 3, because I wanted to cancel out that fraction. When you get in here like 1 and 2, then you start looking at these fractions. Now, another option here could have been like -3, -6, -9, right? So you still have those numbers without getting too big. And then you still have at least 5 data plots. So again, if you've got to look at that bottom number on your fraction and think, what could I put on top of that that would cancel it out, right? Make it a solid number. Okay, so that's 6. Let's look at 8. Okay, so for that, I'm going to move it down a little bit, and I'm going to, and Jace, this is recorded, so you can go back and get the rest of it. All right, so they want us to use a notation to write a rule for each function, okay? So for number 8, I've got a set of, I'm going to go ahead and write these down. -4, 2, -2, and 1. Is that okay or is it fuzzy? Yeah, you guys let me know. Yeah, it'll focus. Yeah, let me know if it's a problem. Okay. 0 and 0. And 2, 2 and -1. And the last one is 4 and -2. So, okay, what we're going to do here is we're going to make an X and a Y table. And basically, we're going to look for a pattern, okay? So remember on these, we've got X and Y. So we're just going to put the first number on top and then the second number. And then we have a -2 and a +1, a 0 and a 0, a 2 and a -1, a 4 and a -2. So what we want to do here is try to figure out what's happening with the numbers. And I'm not even going to lie, I really hate this. Okay, so we went from a -4 to a -2. So we subtracted 2, right? From -2 to 0, we subtracted 2. From 2 to, oh, you know, actually it is adding. Sorry. If we go from if we're going from -4 and then we go like -3, -2, we are getting closer to 0, right? So we're going +1, 2. Okay, so it is adding, my bad. Oh, let me erase. And so now we're adding 2 and we're adding 2. Okay. So I wonder if I should just put that on top. Each coordinate is half the opposite. Okay, let's look at the bottom. So we went from 2 to 1, which means we subtracted 1. We went from 1 to 0, which subtracted. And then we start going negative. Negative. Okay. Okay, another connection here as well is when we're looking at -4 and 2. We went from -4 and 2. It's almost like we divided by 2, right? We're divided by a half. When we have a -2 and it goes to a 1, the 2, that's divided by a half, right? That this would have still applied to 0, 0. That would be divided by a half. And then the same thing here. So I'm going to, we might have something, and what you're going to do next is say, okay, well, I think maybe we're taking X and we're multiplying it by 1/2. Like what would make sense there, right? So if I have my X, I'll have like Y is equal to whatever. I've got a number and then X. What am I doing to X as it goes down? And I'm dividing it. Yeah, we're adding 2, but also when we look at the X and Y, we're dividing by 1/2. So I think I'm just going to also notice that we have a negative and a positive, and a negative, positive, and negative, positive. So I'm going to make it a -1/2 X. And then if I take each Y and I multiply it by a -1/2 X, do I get that same number? So that's what we're going to do. So we're going to take the Y. We're going to plug it in here and then see if our X comes out correctly. So we just have to do this a few times. So I'll have 1/2 times 2. So over here, that would be a -1/2 times 2 over 1. So that'll cancel. Then I'll end up with a -1. Okay. But it's right. What am I looking for? Okay. Good. Okay, so sorry, I was just correcting. I'm looking at it backwards, which is why it wasn't coming out. So what you'll want to do is plug in. So I think if we multiply by 1/2 times that Y, we can, we'll get the correct, no. If we multiply -1/2 times the x, we should get the correct y. So my first one was -4. So I'm going to multiply that by -1/2. Cancel this. Cancel this. And I'll have -2 times -1 gives me a +2 over 1, which does give me a 2. Okay? I am going to try that. Let's try it on one more. You really should try it on all of them. But I'm running out of space and time. So then I'll have a -2. I'm going to put it over 1 because I'm multiplying by a -1/2. Whoops. No, that's not very. So it's over 1 over 2. All right, so these cancel. -1 times -1 is a +1. And that is our answer here. Okay, so this is the function we're looking for. I wish I could tell you there's a really easy way to figure these out. I'm be honest and tell you struggle with them myself because it's hard for me to see those patterns when they're in fractions, but we'll just keep working. Okay, so that was number 8. Let's do number 10. Do the same thing. But we're getting close to done. All right, so number 10. I'm going to, all right, so here's our set. I've got -8, -5, -4, -1.
It's a little better.
Okay, is that better? -3, 0, 2, and 5, 4, and 7. All right, so I'm going to do the same thing. I'm going to make an X and Y table, okay? And then we're just going to start looking at the numbers. Okay, so I've got a -X and a -5, -4, -1, -3, 0, 2, and 5, 4, and 7. All right, so let's start looking for some patterns that make sense here and just kind of see what we've got. Okay, when we go from a -8 to a -4, we're adding 4, right? When we go from a -4 to a -3, we're adding 1. -3 to a +2 would be adding 5. And then a 2 to a 4 would be adding 2. Okay.
X to Y is +3.
Okay, so I'm going to write down +3. So the XY connection Jace was saying is +3. Yep. Yep, those match. Okay. And then from Y to Y, it should look like +4 as well. Okay, so, but well, it should match this. So we'll have +4 here. -1 to 0 is +1. This is +5. And this is +2. So these match. Okay. So it does look like we are adding 3 when we get them. So what would we do? So if we have -8, what would we multiply it by to get a +3 is the question. So remember one thing when we're looking at these numbers, if we're looking at -8 times something gives me 3.
It's 2. But no, it's not. No.
What is -8 divided by 3? So I'm going to kind of just think of it opposite. Okay. So 3 goes into 8.
It's
2
-24.
times. What's -24? 8 divided by 3? Okay, but -8 times 24 doesn't give me 3, right? Hang on one second. So I'll have 2 with
When it's negative,
2 left over.
you go down.
So I'll have like 2 2/3, right?
Mhm.
When it's positive.
So that might even be, I'm going to make it an improper fraction. 6 plus, that would be 8/3. So if I don't know, that may be way out there. What was the answer? Whoa, 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 whoa. Forget all this. Okay, I just peeked at the answer and I'm making this way too complicated. Okay, Jay said it. It's plus 3. So what do I need to do to x to make the y plus 3? Boom. Yes. Okay, so sorry. I was just making this way too complicated. Okay, so it's that simple. There's your function. X plus 3. Yeah. Yeah, so honestly, the other thing I would do differently on these is I would go just straight here. I wouldn't even mess with all of this. Okay, I would just go straight here and see what that is. And real quick, though, we do want to just make sure if we put x in, you just want to check it and make sure your y comes out correctly. So if I have -8 plus 3, do I get a positive or a -5? Yes, I do. If I put in a -4 and I add a 3, and get a -1, and that is correct. Okay, so just make sure that pattern works. Honestly, she's probably going to want to see it for all of them, but this is your answer.
We have 8 more problems.
Okay, so number 12 is next.
Can you like listen to the video if we don't run out of time?
Oh, yeah, of course. Yeah, I'll probably just keep on going. All right, so number 12 is, yep, so same thing. They're going to give you, they've got x and y. Okay, so they're giving you a table, -3, -4, -1, -2, 0, -1, 1, 0, and 3 and 2. Okay, so let's look at that XY relationship and see. -3 to -4, I had to subtract 1, right? -1 to -2, subtract 1, 1 to 0. Okay, so it matches all the way across. Hold on 1 second, I'm gonna, please tell me I'm recording this.
It says
Yes,
recording.
good. Okay, good. So I've undone it a couple of times. All right, let me plug it in real quick. It'll be all from this. Okay. So I'm thinking that our f of x value is equal to x minus 1. Okay, I believe that's our answer. Let's make a quick of x minus 1, and then y. I'm going to plug a couple in. So -3 minus 1 is -4. -1 minus 1 equals -2. Okay, so they are correct, and this is your answer. Any questions about that one? Okay, it's a pretty simple one, right? Okay, so 12 through 33 multiples of 3. Let's jump over to 15. Okay, so from here, they have given you a graph. So my suggestion would be that you make your own chart out of the coordinates. So the first one is -2, 0. Then I've got -1, +1. So I'm just looking at the coordinates and I'm just figuring out how they got there. The next one is 0 and 3. 1, and I went up 1, 2, 3. And then I have got 1, 2, hang on. 1. Okay, I moved over 1, 2. So that one is a 2. And I went up 1, 2, 3, 4. Okay, hopefully I did those right. All right, so again, looking at that XY relationship, from -2 to 0, I added 2, right? Oh man, let me make sure I did that right. So -1, +1. Okay, no, that would still work. It'd be +2 because I have to get through 0. Ah, oh, this is a C. Okay, yeah. So I did make a mistake here. This is 0 and a 2. Now that I can look at it more closely. Okay. That's +2. That's +2. Okay, so we pretty much know here at this point that we've got y is equal to x plus 2. Okay, pretty sure that's our answer. Let's make a quick chart. And just make sure, bye guys. So I'm just going to put in, so I've got like a -2, -1 is 0. Just plug -2 plus 2 is 0. That one's correct. -1 plus 2 should give me a 1. All right, so that's correct. And 0 plus 2 will leave me with a 2. And that one's correct too, 0, 2. Okay, so just make sure that they match up. All right, I'm going to go ahead and pause because I know you guys are ready for lunch. All right, continuing on, we'll look at number 18. Okay, so on number 18, you have a graph, but they really didn't give you coordinates. So if you don't see like, you know, dots on it or something definitive like that, what you're going to want to do is find some solid coordinates. So I'm just going to look at it, and I'm looking for coordinates that fall right exactly inside of a graph. I saw that. Very nice. Good for you. I need mine too. Yeah. Hmm? Okay. I'm gonna holler at him through like Chick-fil-A. Oh, there you go. Boom. Well-run machine. Have a good one. All right. We'll take it. Okay, so just looking, so I'm looking, like I don't want anything that's in the middle or anything like that. So I am gonna go, and I've got +1, 2, 3, 4. So we were 4, and then we went down 1, so it's 4, -1. I'm also going to go with 1, 2, 3, +3, -2. Okay. 2, and then 2 goes down to -3.
Okay. All right. Well, they should be, all right, I'm gonna let you go.
Okay, here we go. So let me go ahead and I'm gonna get one more.
Good job today.
And I'm gonna find that at, let's go 1, and it goes down to -1, 2, 3, 4. So I am just, again, I'm looking for points on this graph that I can see. So if you'll look at in your book, you'll find these as well. Okay, so let's make a chart the way we have been. So I've got X and Y, and I'm just going to plug them in. 4 and -1, 3 and -2, 2 and -3, and 1 and -4. Okay, so the relationship between X and Y was that I go from 4 to -1. I've gone back. Should be adding 5, I believe. 3 to -2, I've gone back 3, and then 0 is 4. Hang on a second. Okay, so just making sure I'm thinking this straight. I got +4 and -1, so I went 3, 2, 1. Oops, sorry, 1, 0. So I went 1, 2, 3, 4, 5. Yes, I added 5. So if I go 3 to negative 2, I'm going 1, 2, 3, 4, 5. Oh, so I'm not adding 5, I'm subtracting it. That's minus 5. 2 to negative 3, so they're going to be the same. Okay, so it's negative 5. So I'm going to propose that our function is y is equal to x minus 5. Sorry, let me pull that up. All right, and I'm going to go ahead and make a quick t-chart and proof that it's correct, and I'm pretty sure it is. Okay, so let's see here. I had 4 and negative 1, so I've got positive 4 minus 5 will leave me with a negative 1, so correct. Next, I had 3, and 3 minus 5 does leave me with a negative 2. So this is correct, and your answer is function y is equal to x minus 5. Okay, multiples of 3 means I'm bouncing over to problem 21. Okay, so it's giving me a chart and it wants me to use function notation to write the rule for each function. Okay, so for 21, okay, now this is labeled x and r of x, so let's write down our coordinates. I've got negative 3, negative 13, negative 1, negative 3, 1, 7, 3, 17, and 5, 27. Okay, so looking at the relationship between x and r of x, negative 3 to negative 13, looks like I subtracted 10. Negative 1 to negative 3. Looks like I subtracted 2. Oh, this is all over the place. Okay. 1 to 7. I subtracted, oh, I added 6. 3 to 17 means I added 14. 5 to 27 means I added 25. Okay, so I'm just going to focus on the positives right now. So if I go to 5, from 5 to 27, I've got 5.
Can I have one of these water bottles?
Yeah, of course. And now I'm going to multiply. I'm probably going to multiply x, right? So I've got this and this. So how did I go from 5 to 27? I know my difference here was 25. So if I took 5 and I multiplied by 5, I'd get 25. Still need to get to 27, so I'm going to try plus 2. Okay, so let me see if that works. So if I'm looking at 5 times x plus 2, let me look at 3x as well. So if I put in a 3, so I have 5 times 3 plus 2, I'd have 15 plus 2 is equal to 17, and that does work. So if you're doing x, 5x plus 2, and that will give me r of x. So I'm just going to plug these in real quick so I can show the relationship. So it's 3 and 5. Okay, so if x is 5, 5 times 5 plus 2, that does give me 27. X is 3, it'll be 5 times 3 plus 2, which will give me 17. And I'll even do one more, so I've got 1 times 1 plus 2 is 7, and that's correct. Okay, so my answer is y is equal to 5x. Oh no, I guess it would be r of x. Yeah, so make it say r of x is equal to 5x plus 2. Okay, that's 21. 22. Right, and that one, they have given us a table. And it says s x and s of x. Okay, so let's plug these in. -2, 8, -1 and 1, 0, 0, 1, -1, and 2, -8. All right, so looking at that relationship, I've got -2 and 8. So I have added 10. -1 to 1. I added 2, nothing. 1 to -1. I subtracted 2. 2 to -8. I subtracted 10. Okay, so I'm just going to focus on 2. I'm doing something to 2, and it becomes -8. What am I doing? And it has to match everything else. Okay, so looking at this, I'm trying to just think of any kind of function I can do to get 2 to -8. So one thing, if I'm thinking maybe I'm multiplying, is I might take -8 and divide by 2. And it does go in -4 times. Okay, so I've got that there. I'm just going to go in 4 times. But then I look at 1 and -1. So I'm multiplying these by something. And I'm either multiplying 1 times -1. But then I need a connection to the 8. So the other thing that you can consider is exponents. Okay. 2. If I take 2 times 2 times 2, right? Well, let's say it's even a negative. Times negative times negative. Of course, it's an odd number, so I know my answer is going to end up negative. But 2 times 2 is, so that would be a +4. Times a -2 would be a -8. So another possibility, and I'm not sure how you would come up with this yourself, but then again, if I have a 1 and I made it, so if it's -x cubed, right, because that's what I did, I multiplied 3 times, that would be, I'm just going to put this in. Okay, so I've got -2, and I said -2 cubed was -8, and that was correct. So let's try 1. So when I put it in, it'd be -1 cubed, which would be -1. Same thing if I had a negative. I would have a -1. So it'd be a +1. So those two would cancel out, and 1 cubed would be +1, which matches my chart. And then, oh, I forgot to do the 2 and the -8. So I'll have a +2. When I put it in, it'll be a negative. It's -x, so it'll be -2 cubed. And when I throw those in again, end up with, oh, so this was a -8. This one would have been a positive because this would have been a -2 again. Okay, sorry about that. All right, so these all match, and my answer is s of x is equal to -x cubed. And that was a hard one. All right, so and I just realized that that is the wrong problem because we're doing multiples of 3. So I'll try to warn you in the email. All right. Yeah, that was a really hard one. I'm glad she didn't give you that. Okay, so number 24 is another graph. We're going to have to look the coordinates on it. Let's see. So again, I'm looking at the graph and I'm just looking for any kind of solid coordinates. So the first one I see is 0, and that goes to 2. I can go over to a -1, and that goes up. No, -2. -2, +3. +2, +1. 1, 2, 3, 4, and 0. Okay, so here's our chart. I'm just going to look for that relationship. All right, so 0 to 2 plus 2. -2 to +3 plus 5 plus 1 and -4. Okay. So this does not help me, so I'm going to look at 4, doing something to it, and it becomes 0. What do I do to it for it to become 1? I'd subtract 1, but that doesn't match. Doesn't match here. Okay, so I'm going to do something to 0 now to make it a +2. The only thing I can do to 0 to make it a +2 would be to add 2 to it. Okay, so I'm going to hold on to that. So if I do something to 4 and I add 2 to it, and it come out as 0, how do I make, I'd have to do something to 4 to make it like a -2, right, to cancel that out. So how do I make 4 -2? Multiply by something negative. Two is half of 4, so I'm going to say negative. Okay, so -1/2 x plus 2. Okay, so let's see. I don't know. Let's just see if it works. So I've got x and y. Okay, so let's start with 0. So if I took -1/2 times 0 plus 2, I get 2. So that one's correct. I'll use -2. I'll have -1/2 times -2 plus 2. So these would cancel. I'd have -1 plus 2, which would give me a positive.
And then I'm like,
Negative 1/2.
well, why is he in the commercials?
Oh, wait. It's times negative
And I'm
2.
like, she's like,
Okay, so that's 1 and 1. These are negative, so it'd be a positive. So it'd be 1 plus 2 is equal to 3. So that one does work. I've got a 2, so negative 1/2 times 2 plus 2 would be negative 1/2 times 2 over 1 would be a negative 1 plus 2, which would give me a 1, correct? And 4, negative 1/2 times 4 plus 2, 1, 2. So that would be a negative 2 plus 2 would give me a 0. Boom. Okay, so my answer is y is equal to negative 1/2 x plus 2. All right. All right. Next up, multiples of 3 would be number 27.
I am so excited for this. PG-13, but my mom didn't want to see it when I was like 13.
All right, so number 27, it says Noel is 2 years older than Angelica, okay? Express his age as a function of her age, okay? So you've got N for Noel, A for Angelica, okay? So he is equal to Angelica's age plus 2. Now it does say a function of, so we're going to go ahead. Let's go ahead and put the A here. So you have N of A is equal to A plus 2. Okay, and that will be your answer. Number 30. All right, the number of cups of flour required for a triple batch of a recipe that calls for C cups per batch. Okay, so I'm gonna I need some flour and I need to know how many cups to make, okay? So whatever the cups are, I know I need 3 times as many, right? Because it says triple batch. So I need 3 times the cups. Boom, there's your answer. And then lastly, I've got 33.
That is so messed up. That is so messed up.
Okay, so that should work. Okay, so on 33, the area of a semicircle with radius r Okay, so here's a circle, here's a semicircle, right? So this is approximately 1/2 of a circle. So area is equal to 2 times pi r, I believe is how it should go. So if I am looking at,
That's a drawing. That's a digital drawing.
oh, no. Area is equal to pi r squared. Okay, but I only want half because it's a semicircle. So I'm going to take area and I just want 1/2 of pi r squared. So if I'm looking for radius r, I'm going to take area of r, and that will be equal to, 1/2 pi r squared. That's how I would solve it. All right, that was 33. Let's look at 49 and 50. All right. Okay, so let's do, I've got 49. Now, they're giving you these problems in x is equal to -3. You don't have to write these down there in your book. I just like to have them. Y is equal to 2 and z is equal to 1/2. Okay, so they want you to solve 49, which says y cubed over x times z. Okay, so I'm just going to plug in the correct numbers. So y here is 2 cubed over x, which is -3, times z, which is 1/2. All right, so I've got 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay. And then I have a -3 times a 1/2. Okay, multiplying straight across, I end up with a -3/2. Now, instead of dividing 8 by -3/2, what I can do is multiply by the reciprocal, right? So I should be able to take 8 and multiply it by a +2/3. So let me see what comes out of this. And that will equal a +16/3. Oh, we're not going to multiply by negative reciprocal, just opposite. Okay, so that'll be a -16/3. Okay, so the answer is -16/3. So you don't have to lose the negative here. You just have to multiply by the reciprocal, sorry. Okay, and the last one is 50. And okay, so this one is 3x squared y z. Okay, so that'll be 3 times x, which is -3 squared. Y is 2, and z is 1/2. Okay, so you can plug this into your calculator. I'm going to go ahead and do the exponent first. So I know it's even, so it's going to be a positive number. 3 squared is 9, so I'm going to have 3 times 9 times 2 times 1/2. 3 times 9 is 27. Okay, 27 times 2 times 1/2. 27 times 2 would be 14. 54 times 1/2. So I'm going to go ahead and solve these. And this is another reason why I like looking at almost fractions, because then I can cross cancel. That would be 25, 26, 27. So that becomes 27/1, which equals 27, and that is your final answer.